Hi everyone, I welcome you all in my ETABS software training series. In my first tutorial I discussed how to install and activate ETABS application into your system. I hope you all have already installed it without facing any difficulty in installation and patching process. If not, I will paste the link in the video description. Today, in this video we will learn how to model a structure, define material properties and assign sections in ETABS. In this lecture series, we will learn to design the structure practically. I will introduce you with real field examples and tell how the structures are designed in the field. So let's begin. The structure we are going to model is a residential building. It consists of ground plus one-story building. You can see various plans on the screens. The architectural plan and sectional elevation is given to you from architect, or if you're good in planning, you can also draw it by yourself. And the beam column layout is designed by a structural engineer. Now the question is how to decide the positions, orientations and sizes of columns and beams. So I will discuss this in my next video in detail. Today we will focus to the basic modeling and defining the structural elements. So let's begin. Open your ETABS application. So to create a new model, click New Model, or you can also create a new model by clicking on the File menu and select the new model. A window will pop up. If you want to go with default settings, then click the first option. If your country requirement is to work with different set of units, then go to Use Built-in Settings. So from there you can choose the different set of units and also you can choose the design codes. For our case, I am going to use ACI 318 2014 for concrete design code. For steel design code, I will be stick to AISC 360. To click OK. Bring you to the new model and quick templates. I will discuss this panel in detail as it is very important to model a structure. So first understand why we have to define the grids and story data at the start. So grid lines are reference center lines of your structure. So grid dimensions are categorized into two panels, uniform grid spacing and custom grid spacing. Uniform grid spacing is used when the size of grid is same in X and Y direction. Most of the time our centerline spacing is not constant along X and Y direction. Then we go with custom grid spacing. So click custom grid spacing and click on edit grid data. Before entering the value of grid spacing, let's have a view to our beam column layout or grid layout plan. So this is the beam column layout. The position of column is marked here. So along x-axis there are 6 grids and along y-axis there are also 6 grids. The dimension between each grid is mentioned here. So I have divided this into a grid layout plan, so it will be easy to mark all the dimension in our ETABS model. So let's begin. In your ETABS model, you can see display grid data as ordinates or display grid data as spacing. So what is difference between them? So if you choose this option as ordinates, that means always whatever the value you choose between the grids, you have to always follow from your origin. For example, if the distance between grid 1 and 2 is 2 and the distance between grid 2 and 3 is 2, so if you choose this option, so for 1 and 2 you will put 2 and for 2 and 3 you will put 4. But if you choose this option, display grid data as spacing, so in this data you have to put the value between A and P, whatever the value is between 1 and 2, and for 2 and 3 whatever the value of dimension is between 2 and 3. So I will tell you in a moment. So I'm choosing display grid data. Open our column layout plan. So from 1 to 2 is 5, fit 4.5 inch. So let's put this value in ETABS. So 1 into 4 feet and half inch, or you can use 4 feet and so the ETABS is smart and it will automatically convert the values. Now begin from 2 to 3. So for 2 to 3 is 5 feet 7.5 inches. Go to your ETABS model. So 5 feet 7.5 inches. Again 4 feet and 9 inches. 4 feet 9 inches. You can add or delete the grid data from these buttons. Eight feet and 10.5 inches. Five feet and 1.5 inch. And from 5 to 6 to 0. Now change the x-axis data from A to B. Value is 8 feet 10 inches. So 8 feet 10 inches. 4 feet 8 inches, 5 feet 9 inches. 4 feet 8 inches, 5 feet 9 inches. 7 feet 7.5 by 8, 5 feet 4.3 by 8. So 7 feet 7.625 inches. Okay, and 3 by 8 is equal to 0.375 inches. So 5 feet 4.375 inches. Okay, so we have added our grid story data. As you can see, the bubbles are overlapping. To reduce the size of bubble, you can insert the different values over here. So 60 inch is higher, so start from the 20 inches. So 20 inch is fine. So no bubbles are overlapping. So this grid data is added. So click OK. Now we have to go and change the story data. For story data in ETABS, you have to provide the story data from the foundation level. So for example, from foundation to plinth level, we have got a certain value. From plinth to first floor level and from the first to roof level. So it will be a 3-story building. So from foundation is generally kept at 1 and 1.5 meter below the ground level. So I'm considering, let's suppose 4 feet or 5 feet below the ground level. 3 feet, our plinth level is 3 feet or 3.5 feet above the ground level, and our first floor level is 12 feet and the second floor level is 12 foot. So this all data will be given from sectional plan, which is given to us from an architect. So let me open a sectional plan. So as you can see, from foundation level to plinth level, it is 8 feet. From plinth level to first floor level, which is 12 feet. From first floor level to roof level, again 12 feet. So we have got 3 story, first story, second story and third story. So let's put this data into the ETABS model. So we have got 3-story building. typical story height is 12 feet and the bottom story height is 8 feet. So we have done with all the data. Click OK. As you can see, the grid line layout is being generated. So first and foremost option is we have to define the material properties. So we are going to design a concrete structure. So we have to define the concrete material property. So go to the define menu, material properties. So ETABS by default has defined different material properties. For 60 grade steel, for 50 grade steel, Fi, yield strength, 4000 psi, which is the compressive strength of concrete at 28 days. So you can modify these options. If you want to add new material, you just click to add new material. Okay. Region, whatever the region you want to select. Click concrete. If you want to change this data, click 3000. Okay. So this is 3000 psi. Concrete, isotropic. So density of concrete is 150. By default, the ETABS has calculated the modular elasticity. We don't have to worry about that. Click OK. If you want to add different materials, because in general practice we assign different types of concrete and home structure. For example, for column we use 4000 psi sometimes. For slabs we use 3000 psi. For beams we use 4000 psi. So in this way you can define different types of materials or the different properties of same materials in this model. So click OK. After defining the material properties, we have to define the section properties. Sections means what types of sections we are going to use in our structure. So there can be beam sections and column sections. So column sections can be rectangular, circular, square. Mostly these all information is given from structural engineer. You have to decide it by yourself which type of column is suitable in this building. So go to the define menu. From section properties, you can define frame sections, slab sections, wall sections, reinforcing bar sizes, and these other options I will discuss one by one in my future videos. So go to the frame sections options. So in our case, columns are rectangular. So the size of column is kept as 12 inches by 12 inches. So go to the add new property, click concrete rectangular section. So our column size is 12 inches by 12 inches. So you can name your column as C. Dimension is 12 inches by 12 inches. And this way we can identify our size of column. So 12 inches by 12 inches. I want to keep 4000 psi for my column. So change the dimension here, 12 inch. Go to the modify show rebar. If you are going to define the column, click here, column, longitudinal bars. You can change the type of bars from this section. If you want to use 50 yield strength bar, you can click here. If you want to use 60 yield strength bar, you can click here. So I'm just keeping the default value. And for confinement ties, lateral ties, you might have seen in columns. So I'm also keeping 60 grade steel. So our column is rectangular. And this option, reinforcement to be checked and reinforcement to be designed. Always go for reinforcement to be designed, because reinforcement to be designed, that means ETABS will tell us the total area of steel needed to resist the load which is assigned on the structure. Reinforcement to be checked, that means if you click reinforcement to be checked, You have to provide all these information. You have to provide the bar size, bar number, number in x direction, number in y direction, what spacing you are providing. So in this way, ETABS will check your given data according to your given data. So always go with reinforcement to be designed. That's why we are using the software. If everything is given by a user, then there is no use to use this software. So reinforcement to be designed. Click OK. Now we have to define a beam section. After, okay, let me go with the modifier show modifier. As we are using ACI 31814 code, so in this code we have to change these values. I will explain the purpose of changing these values in the end of my video. So for torsional constant, the code recommends the value of 0.01. For moment of inertia, about 2x. For a column is 0.70, and moment of inertia about 3x. For a column is 0.70. After modifying these values, click OK. Click OK. So we have successfully defined the column. After defining the column, we have to define the beam. Our beam is normally rectangular. So beam starts with B. So that's why I am using B 12 by 24 inches. So I am assuming this dimension. So depth of beam is 24 inch and the width of beam is 12 inch. Again, go to modify show rebar column. Click beam because we are going to define a beam over here. Beam spacing 1.5 inch, which is kept normally. Again, the longitudinal bars, I'm using 60 grade steel bars. For confinement bars, again I'm using 60 grade steel bar. Click OK. Then go to the modifiers. For torsional constant, ACI code recommends the value for a beam should be 0.01. Moment of inertia about x-axis is 0.35. Moment of inertia about 3x. Again, the value is 0.35. What does it indicate? I will explain later in the end of this video. So all the parameters are defined. Click OK. Click OK. And we have to define the slab as well. Go to the define menu and section properties. The third option is slab sections. So slab, add new property. Slab. Normally slab is assumed with 6 inches thickness. So for slab, we are going to change the material. We are keeping it as 3000 psi. Also change the dimension over here, 6 inches. Click OK. As we have successfully defined the material properties, now we will assign the material properties. So for assigning, as you can see, there are several elements over here. This is element. This icon is used for drawing a beam, column brace, and the description is also written when you put the cursor on this icon. Similarly, this is the quick draw tool. If you want to draw the beam in this grid, just click this option, and by default it will draw a beam between these two grids. Another option is on the bottom of this tab, you can see one story, all story, similar story. Normally our column goes throughout the building, so in order to reduce our effort, we always work with all story building. So I'm using all story. First we will draw the columns. So I've selected the column. From property, we will select the property we have just defined. So 12 by 12 inches. Go to your column layout plan and see the location. A. So along grid A6 there is one column, along grid C6 there is one column, along grid D6 there is another column, Along grid F6 there is another column. As you can see, the center line of this beam is not passing through the center line of this column. But for our case, we are considering the both lines are passing from the center. So why I am considering this? To consider the simple case to model our structure. In actual, whatever the position is given here, you have to model the same position in your ETABS software. So for how to do this? For example, this is 1.5 inches away from the center line, okay, and this is approximately 1.5 inches below from the center line of this column. So for this case, how we will model? So as you can see in property section, there are different sheets. If you want to rotate the column by a certain angle, you have to put some value over here, and automatically your column will be rotated. If you want to place your column at a certain distance from this grid line in x direction, so you have to put some value over here. So this will mark your column away from the center line in positive x direction or negative x direction. Similarly, if you want to do the same in y direction, just put some value over here. If you want to keep model your column away from the grid line in positive y direction or negative y direction, just put some value over here. So for our case, we are considering both lines are passing from the same center line. So as we have seen from our column layout plan, so along A6, C6, D6 and F6, there are 4 columns. So along A6, A6, C6, D6 and F6. So there are 4 columns. So this is the benefit of clicking all stories. Because we are at story 3, we are just inserting the column at story 3 and it is going to replicate on all other floors. For example, if you click only one story, we just click a column over here, it will draw for only one story. It will cost our time. Again, I'm going to click all story. Again, go to our central layout plan. So along A4, C4, D4 and F4, there are 4 columns. As you can see, we have successfully placed all our columns in our model along the grid line. Now we will place the beams. So click this icon to draw the beams. From properties menu, change the property we have just defined. So in order to draw the beam, you have to click at the start point and you have to support the beam at the other end of the column. So our beam is drawn. Similarly, do the same. So to know the exact location of the beam, we have to refer our beam column layout plan. As you can see, from A to F there is a beam, from F to grid 2 there is also a beam. So you have to follow this plan. As you can see, we have successfully modeled all the beams referring to our beam column framing plan. So these icons are used to move along the floors. As we are on story 3. If you want to go below story 3, click this icon. So we are now at story 2. If you want to go up, then click this icon. Roof level. Now we have to place the slabs. So this icon is used to draw the slabs. From property menu, select the property, drag the slabs. As we have selected all the stories, so it will draw the beam along all the stories. If you select similar stories, it will probably skip the foundation level. So as you can see, there is no beam drawn along the foundation level. So again, there is no slab is drawn at the foundation level. Similar stories means the height of story is same. As we know, the height of story from the foundation level to first plinth level is 8 feet, and for rest of the floors, the height of the floor is 12 feet. So in this way, you have to model your slabs. So we have successfully placed all the slabs. Go to the foundation level. We don't want slab here. So from similar story, click one story, click the slab and press the delete button from your keyboard. So this slab will be vanished. Also, at the plinth level, we don't want slab because click all the slabs on this story and delete it. Because this is the first ground level, we just have to place the wall loads along these beams. So let me tell you why property modifiers are important. So property modifiers are very important parameter in defining the section process. They are used to model correct behavior of concrete sections. As we all know that the concrete is weak in tension and strong in compression. Property modifiers are only applied to concrete members only because of cracking. So if we are considering the rectangular section, the total moment of inertia is BD cube divided by 12, we all know that. But when you make this member of concrete, it will experience cracking when loading after some time. So this cracking will occur when concrete reaches its tensile capacity, which is about 7 to 10% of its compressive strength. For example, 4000 psi will have only 400 psi of tensile strength if we are considering 10%. After cracking, concrete is no longer able to carry tension, so steel starts taking the tension. So now, if concrete cracks after 400 psi, the moment of inertia will be reduced because of cracking. If the moment of inertia is reduced, the capacity of section to resist the bending is reduced. Its stiffness is reduced. The concrete will take less moments. Its deflection will increase due to less stiffness. So this moment of inertia, which the cracked beam is not taking anymore, will be redistributed to the other structural members based on their stiffness. That is why ACI Code suggests different values for property modifiers for beams, columns, slabs, and wall sections. Capacity for beam section is reduced to 35% and capacity for column section is reduced to 70%. So guys, this brings to the end of today's tutorial. If you find this tutorial useful, please do like and share. And if you have any doubt, you can comment in comment section. And for upcoming tutorial videos, please do subscribe my channel. Thank you and have a nice day.